13.8 billion years ago, the universe was born from this explosion. This was the most violent moment in the history of existence, an explosion that didn't just destroy, but created everything: space, time, matter, and every particle that would one day form stars, planets, even the human body. Before this explosion happened, there was nothing at all. Not empty dark space, not the kind of emptiness we usually imagine. There was absolute nothingness, no space, no time, no laws of physics that applied. 13.8 billion years ago, that nothingness changed in less than a fraction of a second. That point is called a singularity, smaller than a single grain of sand, yet holding all the energy that would become the seed of trillions of galaxies. Then, in 10 to the power of minus 43 seconds, a number the human brain can barely grasp, space and time began to form. As a result, from that tiny point, the universe began expanding at a speed far beyond the speed of light. Imagine a grain of sand that, in a fraction of a second, grows to the size of an entire solar system. That's what happened in this opening moment, a phase known as cosmic inflation. The first second, an ocean of superheated particles. 1 second after this great explosion, the universe turned into an ocean of particles at a temperature of 10 billion degrees Celsius, hundreds of thousands of times hotter than the core of the sun today. At such an extreme temperature, matter couldn't form anything stable yet. Protons, neutrons, and electrons were still swimming freely, colliding and destroying each other too fast to form atoms. Then, the universe began to expand and cool. As a result, within minutes, not years, not centuries, just minutes, protons and neutrons began sticking together, forming the simplest atomic nuclei, hydrogen and helium. It was like cake batter fresh out of a super hot oven, still too runny and chaotic to take shape, until it slowly cooled and hardened into something with structure. But something strange happened here. Even with atoms now forming, the universe at this stage was still pitch black. No light could pass through the dense fog of particles. This phase lasted 380,000 years, a period scientists call the Cosmic Dark Ages. 380,000 years later, the first light breaks through the darkness. 380,000 years after the initial explosion, something that changed everything took place. The universe's temperature finally dropped low enough, around 3,000 degrees Celsius, for electrons to stably attach to atomic nuclei, forming complete hydrogen and helium atoms for the first time. As a result, the particle fog that had blocked light for hundreds of thousands of years suddenly vanished. Photons, particles of light, could finally travel freely through space without anything in their way. This was the first light that ever existed in the universe. Astronomers can still detect its trace today in the form of the cosmic microwave background radiation, essentially a baby photo of the 13.8 billion-year-old universe. But after this first light appeared, the universe fell back into darkness. Why? Because not a single star had ignited yet. All that existed was hydrogen and helium gas, spread almost evenly across all of space, drifting aimlessly for hundreds of millions of years afterward. 200 million years later, the first stars ignite. 200 million years after the Great Explosion, gravity quietly went to work. The hydrogen gas scattered across space wasn't perfectly even. There were spots slightly denser than their surroundings. These small spots became the root cause of everything that followed. Gravity pulled this gas closer and closer, denser and denser, much like ocean waves piling sand into a single mound on a beach. Then, the more gas that gathered, the stronger its gravity became, so even more gas got pulled in. This was a cycle that kept feeding itself. When this clump of gas became dense and hot enough, reaching 10 million degrees Celsius at its core, something extraordinary happened. Nuclear reactions ignited. Hydrogen atoms began fusing into helium, releasing a massive burst of energy. The first star in the universe had just been born. These first-generation stars were gigantic, hundreds of times larger than our sun today, and they burned extremely bright, but also extremely briefly. Their lifespans were only a few million years, far shorter than the sun's lifespan of up to 10 billion years. Millions of years later, the explosion that created everything These giant first-generation stars eventually ran out of fuel, and when that happened, they didn't fade out slowly. They exploded in supernovae, among the most violent events ever recorded in the universe. These explosions flung heavy elements, carbon, oxygen, iron, even gold, across all of space. Before these supernovae, the universe had only two elements, hydrogen and helium. As a result of these stellar explosions, the elements that make up planets, water, even the human body, finally came into existence. This means every calcium atom in your bones, every iron atom in your blood, once existed inside the core of a star that exploded billions of years ago. 9.2 billion years after the Great Explosion, the Sun is born. 9.2 billion years after that initial moment, around 4.6 billion years ago, in one of the spiral arms of the Milky Way galaxy, a giant cloud of gas and dust left over from an earlier supernova began collapsing under its own gravity. This cloud is called the solar nebula. Picture it like a giant soup being cooked. Its ingredients, gas and dust, kept spinning around a central point, growing denser and hotter over time. About 99.8% of the matter in this nebula was eventually pulled toward the center, forming a clump that was extremely hot and dense. When its temperature reached 10 million degrees Celsius, nuclear reactions ignited once again. The Sun, the star that lights up life on Earth today, had just been born. The leftover matter that wasn't pulled into the center, just 0.2% of the total nebula, kept spinning around the young Sun in the form of a flat disk of gas and dust, resembling a giant spinning platter. Tens of millions of years later, the planets begin to form. Inside the disk of dust surrounding the young Sun, tiny particles began colliding and sticking together. The process was slow at first. It took thousands of years just to form clumps the size of pebbles. But once a clump got big enough, its own gravity started pulling in more material, making the process speed up. Within about 10 million years, these clumps grew into protoplanets, the seeds of planets, already hundreds of kilometers across. In the inner solar system, close to the Sun, only heavy material like rock and metal could survive the young Sun's intense radiation. As a result, this zone produced the rocky planets, Mercury, Venus, Earth, and Mars. Meanwhile, in the outer solar system, far from the Sun's heat, gas and ice could stay frozen and pile up in massive amounts. So, giant planets like Jupiter and Saturn formed mostly from gas, while Uranus and Neptune were built largely from ice. 4.5 billion years ago, the collision that created the Moon, the newly formed Earth, was not a peaceful planet. About 100 million years after its birth, an object the size of Mars, which scientists named Theia, slammed into the young Earth at tremendous speed. The collision was so violent that most of Theia was obliterated, and a portion of its material, along with some of Earth's own material, was flung into space. This ejected material then began orbiting Earth, and over time merged together into a single large object, the Moon. Without this extreme collision, the Moon might never have existed. And without the Moon, Earth's axial tilt would not be stable, meaning the seasons on Earth today would be far wilder and far less predictable than they are now. Hundreds of millions of years later, the solar system finally settles down. After a formative phase full of collisions and chaos, the solar system gradually entered a calmer, more stable phase. 8 planets found their own orbits around the Sun. Leftover material that never got used formed the asteroid belt between Mars and Jupiter, along with the cold Kuiper belt at the solar system's outer edge. It took about 100 million years from the Sun's birth for the solar system we know today to finally take shape. 8 planets, hundreds of moons, millions of asteroids, and one star at the center burning steadily for billions of years to come. From a point smaller than a grain of sand, over 13.8 billion years, this universe eventually gave birth to galaxies, stars, planets, and in the end, a small rocky planet called Earth, where every atom ever forged inside a star that exploded millions of years ago now makes up life itself.